Hey guys, welcome to MySQL series courses from Alibaba Cloud. For this series courses, we will deliver 4 courses to have the comprehensive introduction of MySQL database. So, this video is the first course about MySQL introduction and deployment. So let's get started. Okay, so from this outline, we can see we will have 4 sections. For the first section, we will learn about what is MySQL. From this section, we will know some brief information of MySQL, like history and distributions. So let's move on. From this page, firstly, we can describe MySQL database with one single sentence. MySQL is one of the most popular RDBMs in the world. Here we can get 2 points. The first point is that MySQL is a kind of relational database, which is different from some other NoSQL database, like MongoDB or HBase. And then the second point is that MySQL is quite popular in the worldwide scope. So for MySQL, maybe you can say you never use that, but you can't say you never heard about it, right? And then we will know that MySQL is open source software, which means that you don't have to pay anything to use MySQL database. Even though there are some other commercial version of MySQL, you can still get the free and open source version. Then the next one is that MySQL can support almost all popular operating system platforms like Linux, Windows, even Unix. And the last point is that because MySQL has a very long history, so there are many versions that has been released. But currently, version 5.5, 0.6, and zero point 0.7 are the most widely used version in the world. And for version 8, it is the latest version of MySQL with many new features, but it is not long time since it came out, so it is not that widely used in the world. Okay, for this page, we will learn about these 3 distributions of MySQL. Actually, we can say that even though there are many different distributions of MySQL in the world, but these 3 distributions are the most widely used version of MySQL in the world. The first one is MySQL Server. The first one is Oracle MySQL, which is the official MySQL database release. Because previously we have introduced MySQL now is owned by Oracle Corporation, and for Oracle MySQL, it provides commercial and community version. So you can download the community version and use it for free. And you can also purchase the commercial version to get more features and supports. Another MySQL distribution is MariaDB, which is very widely used in the world also. For MariaDB is created by original creator of MySQL database after MySQL is purchased and owned by Oracle Corporation. So just like original MySQL, MariaDB is free and open source software. You can download it and use it by free. Compared with other distributions, there is a big advantage of MariaDB is that it can provide more new database functions and features. And the last one I'd like to introduce to you is the Percona server. For Percona server, there is also a big advantage is that it has very good compatibility with Oracle MySQL, which means your application can be easily migrate from the Oracle MySQL to Percona server without too many modifications. And um, Percona server will also provide various excellent database management utilities integrated. So if you are database maintainer, the management utilities can help you to finish the database operations such as database monitoring, database backup, and recovery operations. The last point of Percona server is that it will also provide a commercial and community version, just like Oracle MySQL. Okay, so this is the introduction of popular MySQL distributions. Okay, since we have learned about what is MySQL, now let's come out to MySQL structure section and see what is inside of MySQL database in detail. From this page, we will see the structure of MySQL database from top to bottom. The first one I'd like to say is the database connectors. Actually, we cannot say it is part of the MySQL database, but only with the connectors, the applications can connect to database and use that. Like ODBC or JDBC is the method to connect to the database. And the second one is the management utilities, which are the tools to manage the database, such as backup, replication, and clustering. So, management utilities is not used by applications, but used by database maintainers. And the next one is connection pool, which is used to manage cache user uh, connection informations like username and password, privileges, and quantum. So we can say connection pool is the entry of MySQL database service. And the next one is SQL processing related components like SQL interface, SQL parser, and SQL optimizer. They are core components to finish SQL statement processing. And the next one is cache and buffers, which is the memory space to cache the data in the databases. As we know that the data is stored in the disk, and if we want to access the data, we cannot access the disk directly. And we should firstly cache the data in the memory, and then we can access the data from the memory. So the cache and buffer space is used in this way. And the next one is the storage engines. It is used to manage the data processing storage mechanism. Uh, and brief speaking, we can say different engines for different business type. If you want your business to support transactional feature, you should use the InnoDB storage engines. And the next one is the database files. It includes configuration files, data files, log files located on the file system, which all the files will make up the MySQL database. Let's come to the memory structure of MySQL server. Firstly, I'd like to introduce you the MySQL memory assigning principle. It is not pre-assigning, but dynamically assigning while requesting until it reaches the maximum limit. It is work like this. And the second one is that MySQL memory included two parts. The first part is the global shared buffer. Uh, this buffer is used by MySQL instance and the corresponding storage engine to catch all kinds of global computing data and shareable information, like the InnoDB buffer pool is used to um, store the data for InnoDB storage engine. And the second part is the thread dedicated buffer. This buffer is used to store the dedicated data of each of the client connection threads, which means for each of the storage memory space, it is dedicated used. And the data stored inside is such as thread stake information, sort action buffer data, or some other um, buffer data. And the last one I have to mention is that we can configure parameters in the configuration file to customize the database memory as per the business requirement. And then we will learn about the storage structure of MySQL. And for the storage structure, we can divide it into 4 layers of storage from top to bottom. So the first one is the top one, the table space. Table space is the highest level object of the database. And our database logical objects like segments stores in table space. And by default, for one single tablespace will have multiple segments stored inside, but we can set a NoDB file per table, this parameter, and to store each table in dedicated tablespace. And the second layer of the storage is segment. Segment generally is corresponding to each logical object in database, like tables, indexes, or other logical object. And the next thing is that segment is consists of multiple extents. So let's see what is extent. Extent is the connection of multiple successive pages. Okay, so let's come to the lowest layer of the storage, page. What is page? Page is the minimum unit when the database is assigning space. So, uh, and the next one is that for each page is in size of 16K. So this is what the storage structure is like for MySQL from top to bottom. For this page, we will learn about the file structure of the MySQL server. Uh, there are generally 4 types of files that consist of MySQL. The first one is the parameter files, which is uh, named my.conf. This file, at most of time, we will edit it to change some parameters inside of it. And the second type is the data files. Generally, it's located under var, lib, and MySQL, this directory. And for this type of data, it contains most of the data that are inside of the database. So we can use show variables like data_dir to check the location of the data files. And the third one is the log files. For log files, generally it has 2 kind of log files. The first one is we can say it is the transactional log file. It is bin log files and redo log files. This kind of log file is used to record the transactions of the databases. So you cannot see the content inside of it directly. It's just used by the database inside. And the another kind of log file is error log file and slow query log file. These log files is in text mode, which means you can use text editor to open it and see what is the content inside of it. And all of these files, log files, you can use show variables like this circle statement to check the location of these log files. And the last type of the database files is some other files like PID files and socket files. For these 2 kind of file, you don't have to manage it manually. You just need to know the name of the file and the location of the file. So after we have known what is MySQL and the MySQL structure, in this section, we will learn about the MySQL installation. After we learn about this section, we will know how can we finish the installation for the MySQL software and the database. Okay, so for this example, here is some prerequisite of the example. So for the firstly, for the MySQL version, we will use version 5.7, and we will do the installation on the operating system Sensitive OS 7.3. And we will use yum as the installation method. For the first step is that we should download MySQL yum source config rpm package with the following command. Here we can see we will use the wget command to get the RPM package from the internet. And then after that, we will install MySQL yum source configuration RPM package. And then after we have finished the yum source config package, and then we can use yum to install the MySQL binary. For this step, maybe it will take a long time to finish all the related packages, so please wait. And then after you have finished the MySQL binary installation, you can try to start the MySQL demo with the command systemctl start MySQLd. With this command, you can start the MySQL demo, and then you can check the status of the MySQL demo with the systemctl status MySQLd to check whether it's active or not. And after you have started the MySQL demo, the next thing is that maybe you should connect to the database server, right? So for the first time you connect to the database server, you should know the root password. And by default, the uh, MySQL server will generate a temporary password in the var log mysqld.log this file, and you can find the temporary password in this file, and then you can use the password and log in on the MySQL server with root account. And after you have finished all the installation of the MySQL server, and you can maybe you can edit the configuration file of the MySQL server to make it satisfy your business requirement. Maybe you should change the memory configuration or the location of the data files or something else. Okay, and after we have learned about all the things above uh, about a MySQL server, so in the last, I'd like to introduce you how to use MySQL on Alibaba Cloud. The first thing that I'd like to introduce you about Alibaba Cloud is the RDS, which is short for Relational Database Service. And RDS is a stable, reliable, and scalable online relational database service on Alibaba Cloud. And on the RDS platform, you can apply all kind of database versions, not only for MySQL, but also for SQL Server, for PostgreSQL, or for PPAS. Which means if you want to use MySQL, you can use the RDS platform. And for the MySQL on RDS, it can support 5.5, and zero point 0.7 version, which means it can cover most of the widely used version in the world. And the next one is that MySQL on RDS can support InnoDB engine. And so from this picture, we can see the steps that how can we provision a MySQL instance on RDS platform. Uh, Here we can see that if we are using, um, so from this page, we can see that it will be very easy to provision a MySQL service on the Alibaba Cloud RDS platform. And uh, not only the database service, you can also do some more things on this platform. For example, if you want to control the access to the database, you can set the IP whitelist for your database. And if you want to access the database from the internet, you can also apply an internet address for your database instance. For these two features, if you want to achieve it on the self-installed database service, it will be very difficult. So we can see that uh, Alibaba Cloud RDS platform is a very powerful database platform. Okay, so this is all the things about today's first time course. Thank you for listening. See you next time. Welcome to MySQL series courses from Alibaba Cloud. Today's course is about high availability introduction of MySQL database. So let's get started. So for the first section is about what's the benefit that we can get from the high availability architecture of MySQL database. From this page, we can see, and most of time, we can get two benefits from the high availability architecture. The first benefit that we can get is the fault tolerance, which means it can avoid single point failure on computing layer. At the same time, it can avoid single point failure on data layer. On computing layer, it means if one server is crashed, another server can continue to provide the database service. And on data layer, it means if one disk is, is broken, and then it will not cause the data loss. And the next benefit is the load balance. Because we will know that if we have high availability architecture on the database, we will not have only one instance for one database, right? So with several instances, we can separate the database read and write request to achieve load sharing. And at the same time, we can separate database business and maintenance operation to avoid the maintenance operation will affect the business. This is a very big benefit. Okay, so let's go to the next part. Okay, after we have learned about the benefit that the MySQL high availability architecture have, we will learn about MySQL high availability solutions that is widely used in the worldwide scope. So let's get started. The first HA solution of MySQL database that I want to introduce you is the MySQL replication. Actually, this is the feature that is integrated with the MySQL original software. You don't have to install any extra software to support this feature. And for the MySQL replication, the minimum nodes quantity is 2 or more. Key theory of MySQL replication is based on bin lock. On the master node, all the changed data will be logged in the bin log, and the bin log will be replicated to the slave node. The slave node will apply the bin log to itself to keep itself synchronized with the master log. This is the working theory of the replication. And the advantage of MySQL replication is quite obvious. Firstly is what I have introduced. It is integrated with the original MySQL software, which means you don't have to install any extra software to support this one. Secondly is that it is very easy to configure. What you need to do is just to change the configuration in the myconfig file, and then you can establish the replication. And the third one is that MySQL replication have a very simple architecture that it just need 2 nodes only. Because for some other replications or clustered, it need 3 nodes or more to build up the replication cluster. So we can say MySQL replication has a simple architecture. But the MySQL replication also have disadvantages, such as the MySQL replication is using asynchronized replication, so it cannot guarantee the data consistency between the master and the slave, which means for some moment maybe some data has been changed on the master node, but on slave node it hasn't been changed. So if you have read the data from the slave at that moment, maybe you cannot get the latest value. The next HA solution I'd like to introduce to you is the MySQL cluster. MySQL cluster is the official cluster software that is provided by Oracle Corporation, and it requires at least 3 nodes from other cluster software. For other clustering software of MySQL, at most of time they are using the binlog as the replication media. But for MySQL cluster, it is working like this. It has two kinds of nodes. The first one is the circle node. It is used to run MySQL servers and process. It is the access point of the database. We can just briefly say circle node is the node that run a MySQL instance on no data. And the second type of node is NDB node. It stores all data of the database. And NDB storage engine will guarantee the data consistency and the redundancy. So it will not use the bin log. And as the official clustering software of MySQL, it has many advantages. Like with the help of NDB storage engine, it can provide very high data availability, redundancy, and consistency. And with the NDB nodes, it is designed in no sharing data architecture. And it also has a very high scalability. It can support online node expansion without stopping the database service. But it also has many disadvantages like the configuration and the troubleshooting for MySQL cluster is very complex because there are many nodes that has designed in the architecture. And the second one is that it has high memory required on NDB node to speed up the I/O performance of the cluster. So the hardware requirement may be a little high. And the third one is that it has high network requirement between the NDB nodes because there are a big amount of data that should be synchronized between the NDB nodes. So this is MySQL cluster. The next clustering software of MySQL database that I want to introduce to you is the Galileo cluster. This is the third-party clustering solution, which means you should install the Galileo cluster software uh, separately. And the minimum node requirement for Galileo cluster is more than 3 nodes. And just like MySQL replication, the Galileo cluster working theory is also based on binlog. But the difference is that, firstly, all the nodes in the cluster are master node. There isn't any dedicated standby node in the cluster. And the second one is that Galileo cluster will use WSREP process to synchronize and change the data across all nodes in the same Galileo cluster with binlog. So this is the difference between the Galileo cluster and the MySQL replication. So it has many outstanding advantages like below. The first advantage is that, just as I mentioned previously, all the nodes in the cluster is master node, so it can support write on multiple nodes. And the second one is that it has a very high data availability, redundancy, and consistency based on the replication mechanism. And the third one is that it can automated detection on node failure and recovery. And it also has disadvantages like it only supports NoDB storage engine. And secondly, you should install extra Galileo cluster software to support this feature. This is not an integrated feature for the MySQL software. So this is what Galileo cluster like. Okay, let's come to the next solution is the DRBD replication. Actually, this kind of solution is quite different from what has mentioned above. Uh, for the above mentioned solutions, all of them is based on the database replication. But for DRPD replication is based on storage replication. So the working theory of DRPD replication is like this. First, database files is stored on the block device of Linux OS, right? And then DRPD can achieve data replication in the Linux blocks device layer. So um, in this way, it can make database HA in the OS device layer. So with this solution, it will have advantages like first one, DRPD is integrated in the OS, so it's easy to configure. You don't have to install any extra software. And the second one is that it has simple architecture with two nodes only. You don't have to install many nodes to support the clustering. And then the third one is that it has high data consistency because the replication is based on storage layer, right? So in the storage layer, you don't have to worry about for some data loss when the database is replication. But on the other hand, it also has some disadvantages. The first one is that as the testing result, we will see that the DRBD will have a little high I/O impact on the database, which means during the DRBD replication, the disk performance on the master node will be affected. And the next one is that the database on the slave node is not readable because the replication for DRBD solution is based on storage replication. So on the slave node, you cannot bring up the database. Then you cannot access the database, even in read-only mode. This is the disadvantages of the DRBD storage replication. Okay, let's come to the last MySQL high availability solution that I'd like to introduce to you is the SAN shared storage. For this solution, actually we can say this is the traditional database solution that in the old time, which means we will have two nodes acting as master and slave, and we will have a centralized shared storage to contain the data. So the working theory of this solution is like this. The database file is stored on the block device, which is from the SAN shared storage. And then both master and slave node can access the shared storage, which means we have two uh, database node, but we just have one database storage. And then when the master node is down, the slave node will take over the storage and continue to run the database. So this is the mechanism of this solution. And for this solution, it has advantages like it has no data replication, so it will have high data consistency. You don't have to worry about the data loss during the data replication. And then the second one is that it has a simple architecture with two nodes only. You don't have to configure many nodes to support it. But on the other hand, it will have some disadvantages. Like the first one, data redundancy on the SAN shared storage should be taken in consideration because it's different from the mentioned solution above. You will have only one database data installed. So you should make sure that your SAN shared storage will have a very high data redundancy, like protected by read technology or some other technologies. And then the second one is that the SAN storage and the SAN network at most of time is expensive, right? So you should spend more money to buy this kind of hardware to support this solution. So this is the SAN shared storage solution. So after we have known various kind of HS solutions for MySQL database. In this section, we will take a MySQL replication as an example and show you guys how can we set up the database replication. So this is the prerequisite of the installation guide. And for the MySQL version, we will use 5.7, and for the operating system, we will use CentOS 7.3, and we will prepare two nodes and build up the bidirectional active and active replication, which means both of the nodes will act as the master node and slave node at the same time. And the replication will from node 1 to node 2, and at the same time also from node 2 to node 1. Okay, so for the first step that we configure the MySQL replication is that we should add the MySQL configuration on the node 1 as following. These configurations is used to build up the replication between the node 1 and the node 2. And then the first step is that we open the myconfig file and add all the list parameters in the configuration file, and then we save the configuration file, and then we restart the MySQL demo. And the next step is that we will create a user for replication on node 1 as master node, which means this account will be used by the node 2 to transfer the bin log from the node 2 to node 1. So we can use the command list here to create the account. And the next step is that we should do the same configuration as node 1 on node 2. First is the same. We should add the parameters in the configuration file. And for this step, we should pay attention that there are two parameters that we should set different values as node 1. First one is the server ID, and the second one is the auto increment offset. These two parameters we should set different values to avoid conflicting with node 1. And then we should create the same account on node 2 for the same purpose. Next step is that we should configure the master node as node 2 for node 1 with the following comment. Actually, for this step, it is like now you are telling the node 1 that node 2 is your master and now you are slave. And then after we have changed the master to node 2 for node 1, then the next step is that we should start the slave process on node 1 and with command start slave. After we have run this command, we can use command show slave status to check whether you have do it successfully and whether the status is normal or not. You can check the slave IO running and the slave circuit running, these two values. If both of them is yes, which means you have successfully started the slave process for node 1. And then after you have finished the actions, you will do the same thing on node 2. Just do the same thing on node 2 to change the master as node 1 for node 2 to tell node 2 that now your master is node 1 and now you are slave. And then after you have run this command, just start up the slave process on node 2 with command start slave. And after you run this command, you can also check the status with show slave status and check the slave IO running and the slave circuit running. These two values, if both of them are yes, which means you have do it successfully. Okay, after we have finished all the steps that listed above, actually we can say we have finished all the configurations of the MySQL replication and we have established the replication. Now for the last step is that we should verify whether the replication is working normally or not, right? So we can do like this. First, on node 1, we can create a new database with the command shown here, and then we can log in on the node 2 and use the command show databases and see whether the new created database on node 1 has been replicated to node 2 whether or not. So this is the way how can we verify whether the replication is working normally or not. So after we have learned all the things above, we have known what is high availability architecture of the database and what is the most popular HA solutions in the worldwide scope, and then even how can we manually create a or MySQL database replication step by step. So after all these things, I'd like to introduce you how can we use the HA features of the MySQL on Alibaba Cloud. Just as what I mentioned in previous section, it is not easy to configure the MySQL replication by yourself. Even with the most simple architecture, you should have to change all kind of configuration files in each node, and maybe you will make some mistakes and to configure some parameters in wrong value. So you should do sharp troubleshooting. It is a complex task, but if you are using Alibaba Cloud MySQL, and you don't have to worry about this kind of issue, Alibaba Cloud RDS can provide you different versions for different uh, data protection level. For example, if you are using the high availability version, it will provide you a two-node replication MySQL cluster. And if you have a higher data protection requirement, you can use the financial version. It will provide you a three-node MySQL cluster. So as long as you are using Alibaba Cloud RDS MySQL version, what you need to do is just use the database, and the data protection, the high availability, you don't have to worry about it. These things will be uh, take responsibility by Alibaba Cloud. So you just need to use the database. Okay, this is all the things about MySQL high availability introduction course. Thank you for listening. Bye bye. Hey guys, welcome to MySQL series courses from Alibaba Cloud. So today's course is about database backup and recovery. So let's get started. And for the first section, what we are going to learn about is different types of database backup and recovery mechanism, and some relevant comments and parameters. So let's move on. The first thing that we should clear about is that why we need a backup. As we all know, the database always plays a very important role as the core of the information system, especially in some industries with high data reliability, like telecommunications or financial industries. So, if unexpected downtime or loss of data happened on the database, it will be a very critical situation. So, under this situation, the database must be created by a very reasonable backup strategy to ensure the high availability of the data. So that's why we need a backup. And then when we're talking about backup, at most of time it will include two methods. The first one is the logic backup, and the second one is the physical backup. So we will learn about logic backup first. And the first thing is that what is logical backup? Generally speaking, for a database system, logical backup is to backup the logical object in the database. So what is logical object? We can say that all the tables or indexes or other kind of objects like this inside of the database is called logical object. And here we have shown a example how can we do a logical backup on our database with the command MySQL dump. With this command, we can do a logical backup on our target database. And in this command, and you can see there is output file named test.sql, right? So the name of the backup file is test.sql in this current directory. And we can open the backup file to check it. And you can see that all the information in it is SQL statement. From here, we can know that with this SQL output file, all the SQL statement inside of this file has defined all the logical object in the target database. That's why we say this is logical backup, which means with this backup command line, we can back up all the logic object inside of the database. For previous example is just one of the most common simple backup command. We may encounter a variety of different situations. For example, for sometimes you need to write the database creation script together, or sometimes you need to export a number of databases or even all the databases in one database server. And for sometimes only a few tables need to be exported. So in this case, we need to use different parameters to control the result that we want to export. And the next page, we will learn about the parameters that we can use to control your export action. The first parameter that I will introduce you is the parameter named all databases. If you add this parameter, when you export the database, it will export all the databases that in this uh, MySQL server are not only one databases. And another parameter is add drop database. If you add this parameter when you export the database, it will add the drop database statement before each create database statement in the backup set file. So with this parameter, we can avoid uh, the target database will have the same name of the existing database. So when we are going to restore the backup set to the target database, firstly it will drop the database with the same name and create a new database. And the third parameter is add drop table. Uh, this is the same way as the add drop database. It will add the drop table statement before each create table statement in the backup set file. Uh, in the same way to avoid the same name of the table has existed in the target database. So when we are going to restore the backup set file to the target database, firstly, it will drop the same name table in the target database and then create a new table. The next parameter is the add logs parameter. If you add this parameter before you export the database, for each table, before you export this table, firstly it will lock the table and then the exporting will begin. And then after the exporting is finished, and the table will be unlocked. So with this way, we can make the export data consistent. And the next one is the comment parameter. With this parameter, you can choose to export the comment of the table or not. If you don't want to export the comment of the table or some other object, you can use skip comments, this parameter, to cancel it. This one is easy to understand. And the next one is compatible parameter. This one is a very useful parameter. With this parameter, you can make your backup set file compatible with some other version of the database system, like PostgreSQL or Oracle software or Microsoft SQL Server. So if someday you want to export your data from MySQL and import it into some other database system, you can use the compatible parameter to control it. The next parameter is compact. If you don't use this parameter by default, the backup set file will contain some annotations and description statements. Uh, but after you have added this parameter, uh, all these annotations and description statement will be deleted, just left the real functional SQL statement. And the next is complete insert parameter. With this parameter, all the insert statement in the backup set file will contain the column name, uh, which means this can increase the insertion efficiency, which means if you have insert a big amount of data in the table, it will be fast. But it may be affected by maxima allowed package parameters and result in insertion failure. So for this parameter, you should control it by yourself to avoid this kind of failures. And the next parameter is the databases parameter. This something in sync with the first parameter that I introduced you, the all databases. With this parameter, you can assign some specific databases that you want to export, not all the databases. And the next one is default character set. This one is easy to understand. We use this parameter to control what is the default character set when you're exporting your database. Okay, after we have learned about all the parameters that are used to export the database, here in this page we will learn about how can we recover a database. As I mentioned previously, in the backup set file, all the things inside of the file is the SQL statement, right? So compared with the backup operation, the recovery is much more easier. So if we want to recover the database, what we need to do is just run the backup set file as the SQL script instead of the MySQL server. Here is the command example. We can use MySQL command and just use the backup set file as the input of the MySQL command, and then the MySQL will execute all the SQL statement in the backup set file and finish the recovery. Or you can just log in the target database and run the backup set file as a SQL script with source command, and then all the SQL statement in the backup set file will be executed. And after all, the database recovery will be done. Okay, so after we have finished the logical backup, let's come to the physical backup. First thing that we should know is what is physical backup. Generally speaking, we can say physical backup is to save all the physical files of the database. For example, after creating a database, MySQL will create a DB directory under the data.dir directory, right? And put all the files inside of the data.dir directory. And then if we save all the physical files under this directory, we can say this is physical backup, which means we will backup the files are not the logical object inside of the database. And at most of time, physical backup is suitable for backup large amount of data. So here we can see a command example like this. Here we can say we are using extra backup tool to do the physical backup. Actually, for MySQL software itself, there is no physical backup tools integrated. Just the MySQL dump, the logical backup tool. But for physical backup, we should install the third-party tools to do. So here we suggest to use extra backup tool to do the physical backup. And for this page, we will show you an example about how can we finish one-time physical backup of the database. First step is that we should create a user for backup and give the relevant privileges. Uh, and this is the command line maybe that we will use. And then the second step is that we will create a backup directory, and during the backup, all the backup set file will be right inside of this directory. And then the last step is that we will use command to start the backup. We will use the command no backup ex this command to to run the backup. And then in this command line, we can see we will assign the configuration file of the database, the user that we used for backup, and the password of the user, and then the directory that we want to put the backup set file inside. And after the backup has finished, we can check the result of the backup file, which means all this file is included in the backup set. The first type of the file is the directories that store the database files. Here we can say in this example we have 4 directories generated, which means we will have backuped 3 databases in this example. If you have backup some other databases, it will also have individual directories to store the database files. And the second one is the uh, backup my.conf file. For this file is the backup of the configuration file of the database server. Actually, we all know that for each of the MySQL database server, we will have a main configuration file like this, right? So this is the backup of that configuration file. And the next one is the LB data one. This is the backup of the shared table space file. Shared table space file. And the next one is the extra backup checkpoints. For this file, is include the backup types, backup status, and the LSN range information. It is all the information that's about the backup task. And the next one is the extra backup info. This file will record the basic information of the backup, like the UUID, the backup comment, backup time, bin log, LSN, and other encryption or compression information. And the last one is the backup log file. This is the backup set file of the redo log. Redo log. So this is all the files that are included in one whole set of the backup set file. Okay, after we have known how can we finish a database physical backup, for this page we will learn about how can we finish the physical recovery with the existing backup set. So in this example, first we will simulate that we have deleted all the database files. First we will stop the MySQL service, and we will remove all the related files and the directories. And then we will begin to recover the database. The first thing that we should do is use the no backup ex command to prepare the backup set ready to recover, and we will use the apply log parameter to make it. And then the next step is that we will also use a no backup ex to finish the recovery procedure. After this command finished, actually we can say all the files has been recovered in the previous location before the deletion. And then after this command has been finished, we can say that the recovery has been finished. But the next step we should do is that we should verify whether the recovery is successful or not. And then now we can try to restart the MySQL demo process, and then we can use the command show databases to check whether the database information is the same with the previous one. Even we can go inside of the database and check whether the tables is still there. Okay, so for the first section, we have learned all the things about database backup and recovery. And for the second section, we will learn about how can we do database migration. Okay, so let's move on. So the first thing that we should know is that what is database migration? For generally speaking, database migration is defined to migrate data from one database to another. So this is called database migration. And the reason for database migration may be server upgrade, for machine migration, equipment update, or database segmentation. And the most common used method of database migration is to use backup set and restore data to the target server. So for database migration, generally speaking, we will have four steps. Firstly, we will back up the database that need to be migrated. No matter you are using logical backup or physical backup, you should back up your database first. And then secondly, you should copy the backup set file to the migration target server and prepare the database environment. And after this step, the third one, you can recover data on the target database server. Then until this step, we can say that we have finished the data migration from the source server to the target server. And then the last step is that we should check whether the new database in the target server is consistent with the source one. This is the four steps for database migration. For each of the steps, maybe it's related to database backup and recovery, but generally speaking, we can say with these four steps, we can finish the database migration. So after we have learned about the database backup and recovery and the database migration, let's see if we are using Alibaba Cloud RDS MySQL, what will the database backup and migration be like? So let's move on. So now if you are using Alibaba RDS service, you can get the regular backups, which improves disaster recovery capabilities and increase overall database efficiency by ensuring data is backed automatically using object storage service. And talking about recovery, Alibaba RDS can provide easy recovery options, which allows you to save point-in-time snapshots of document and log files over the last 7 days to eliminate risks like data loss or data corruption associated with your stored data. So talking about database migration, you can take advantage of DTS service, which is provided by Alibaba Cloud also. And with this service, database can be migrated easily from RDS to RDS or from your original or traditional database service to the RDS. No matter what, it will be make you very easy to migrate your database. And one more thing is that the data migration is processing online with DTS service. This is a very big advantage. Okay, this is all the things for MySQL backup and recovery course. Thank you for listening. See you next time. Hey guys, welcome to MySQL Serious courses from Alibaba Cloud. So today's course is about database monitoring and maintenance. So let's get started. For the first section, we will learn about how can we check the MySQL running status. Let's move on. The first point is that Acting as a database maintainer, what is the purpose of the running status check? When we have just connected to a MySQL instance, we need to have a basic understanding of the running status of the current MySQL instance, right? Such as whether the service is running and how many active actions connections are currently available, the time of abnormal operations after the last startup, and so on. So here we will learn about some command that we usually use to check the overall status of the database. The first command that I'd like to introduce to you is the MySQL admin. With this command, you can get many informations of the MySQL database. You can combine this command with different parameters, like if you combine it with ping, and you can get the MySQL service is running or not, and you can use the status parameter and you can get the current status of the MySQL instance. And then you can also combine it with process list parameter and you can get the current connection information. And another way that we check the database information is that we can use the MySQL command. This command is used to connect to the database, right? And we can combine different SQL statement like select and show or some other SQL statement like this to check the information inside of the database. Like we can just as shown in the fourth example, we can get the number of the current connections, and the next one we can get the last running time, and the final one we can get the size of the DB using space. So with this way, we can just use the MySQL command and combine it with many different SQL statements to get the information. Okay, so then the next section is about MySQL performance check. After we have known how can we check the running status of the database, we should also know how can we check the performance status of the database. First, we should know what is the purpose of the performance check, because as the database maintainer, we should know not only whether the database is alive or not, but also we should know whether it is working in a health mode, which means if the database is alive but it is not working in a health performance mode, then it doesn't mean anything, right? So uh, at some levels, we can say the performance of the database is the same important as the overall status of the database. So we usually use the following command to check the performance of the database. Just as the example shown here, we can use show global and combine it with different kind of keyword to get different global performance statistics of the MySQL database. And just to see the first one, we can get the QPIs of the database, and the second one, we can get the uh, key buffer heat ratio of the database, and the third one we can get the InnoDB buffer heat ratio of the database. For the buffer heat ratio, we can say that it should be as high as possible. A higher buffer heat ratio means the database will have a bigger and higher performance level. And for this page, it is also the show global statement. With this statement, we can also check some hit ratio and status statistics. Like the first one, we can get the query cache hit ratio, and the second one, we can get the table cache status. And the last one, we can get the thread cache hit ratio. And for this one, usually it should be more than 90% to have a better performance. And this page is also the for some status that you can check with show global SQL statement. And so we can see from the past three slides is that we can get most of the database performance statistics data with the show global command line. Okay, so for the third section is about how can we check the MySQL parameters. Actually, just like if we want to check the global performance statistics of the database, we can use show global SQL statement, right? And if we want to check the parameters, we can use the SQL statement like show variables. And with this SQL statement, we can get all the parameters that the database have. Or we can just combine the show variables statement with different kind of keyword to get different parameters that contain that keywords. Here are some uh, keywords that is usually used when we check the parameters of the database. The first one is the data dir. This keyword is used to check where the data files located in the operating system for this MySQL database. And the second one is the character set. It's used to check the character set value of the database. And the third one and the fourth one and the fifth one is all of them is used to check the location of the log files. Different log files maybe have different locations. And the next one is the default storage engine. This parameter is used to define which storage engine the database will adopt, like InnoDB or ISMISA. And the next one is the connections and the max user connections. Is used to check the maximum connections that the database have and the maximum connections that for each user it will have. Besides these parameters, there are also many other parameters that you can check with show variables and combined with different keywords. Okay, so for the fourth section, I'd like to introduce you about MySQL error logs. At most of time, we just consider error logs is used to record the error information of the database system, right? But for MySQL, it is not only used to store the error information of the database, but also used to store the major event of the database, like database shutdown and database startup. So this is a difference between the MySQL error log with some other systems. And the name of the error log is usually hostname.err. The hostname is the hostname of the database server. And the information in the error logs at most of time can be used to do troubleshooting to determine whether the database is running or not, or to determine the reason why the database has crashed. And if we want to know the location or the name of the current error log file, we can use the SQL statement show variables like log error. With this SQL statement, we can get the name information of the error log. And but it is not a confirmed information because we can also assign the location and the name of the error log file when we start up the MySQL process. Here is an example. We can when we start up the database with MySQL start, we can add the log error parameter and assign the location and the name of the error log file. And then after that we can check it with show variables like log error to check whether we it has been changed to another location and a name. And for error log, we should do archive and backup, because if the error log is not clean or deleted, it will continue to grow. It will not do the rotation automatically, so we need to do the manual cleanup work. Before MySQL version 5.5.7, uh, we can delete the error log through the command MySQL admin and add the flash logs parameter to do the error log rotation. But after the version 5.5.7, we need to manually rename the file to finish the log rotation. First, we can use the mv command to move the error log to some other place or to rename it, and then we can use the MySQL admin command and add the flash logs and to create a new error log, and then we can archive the old error log to some other directories or to some other places. And the next section is about OS status check. Because as we all know that the MySQL database should depend on the operating system platform, right? It cannot be running independently. So we can sometimes help us to judge the performance of the database instance by checking the status of the operating system. Here is some command line that we can use to check the status or information of the operating system. First one is the free command. With this command, we can check the overall memory usage of the operating system. If here you notice that maybe the memory usage of the operating system is almost used up, you should pay attention of the performance of your database. And then the second one is the df. With this command, you can check the file system usage on the operating system. If you notice that the file system usage is most full, you should pay attention, because if the file system is full, your database cannot be running normally. And the next one is the IO state. With this command, you can check the disk IO performance status and also the CPU usage. If you notice that the disk IO is very high and the disk now is running the database, you should pay attention whether the database have some issues, or the business is very big. And the next one is the net state. With this one, you can just check the brief information of the connection information in OS layer. And you can also check the operating system information with some other command line that is related to the database running. So until now, we have learned many things about the MySQL database maintenance and monitoring skills. So let's see, if we are using MySQL on Alibaba Cloud, how can we maintain the database? And here we can say if we are using the MySQL service on Alibaba Cloud RDS, it can provide you automated monitoring and maintenance on the database layer. And at the same time, it will also provide automated resource scheduling, platform health monitoring on infrastructure layer, like server layer or storage layer. And then it will eliminate duplicated manual works. So finally, it will save human resources for database maintenance in a very sharp degree. So generally speaking, we can say if you are using MySQL on the Alibaba Cloud platform, you don't have to do any maintenance work in your daily works. What you need to do is just focus on your own business. Okay, this is all the things for MySQL maintenance and monitoring course. Thank you for listening. Bye bye.